Welcome to my presentation. In this presentation, let us try to see an example problem which will explain how to find the eigenvalues and eigenvectors. Let us take an example here. In this example, if A is a matrix and if the elements of these matrix are 1, 4, 2 and 3, we want to find the eigenvalues and corresponding eigenvectors for this type of situation. So what we know is, let's write these down in these different steps. What we know from the characteristic equation of matrix A is that if we were to let the determinant of delta I minus A to 0, then we should be able to write out the polynomial in delta, and then we can then find the values of the eigenvalues delta. And the way to do that is as follows. The determinant of delta I minus A is equal to 0. Delta is the eigenvalue and I is the identity matrix. Since the given matrix is a 2 by 2 matrix, the identity matrix we're going to select here will be a 2 by 2 matrix, and it looks like this: 1 0 0 1 minus A is the given matrix 1 4 2 and 3, and we're going to let the determinant of that equal to 0, and I'm going to write on both sides in here. So this one I can simplify as follows. I'm going to distribute the lambda to every one of the terms in the identity matrix, and that's going to look like this: lambda 0 0 lambda, and then minus 1 4 2 and 3, and the determinant of that we're going to equate that to 0. Let me explain that some more. And then here we're going to perform the subtraction of two matrices. That is going to be as follows: lambda minus 1, we're going to take the first element of the first matrix and subtract the first element of the second matrix, lambda minus 1, and then we're going to exhaust all the elements in both the matrices. Then we have 0 minus 4, then we have 0 minus 2, and then we have lambda minus 3. And this is we're going to let the determinant of this equal to 0. We can also write this one out as follows. We're going to expand this, and the way to expand this one is as follows. We're going to multiply the major diagonal elements and write them out there, and then that is going to be lambda minus 1 times lambda minus 3 minus, we're going to then multiply the minor diagonal elements and write the product there. And the way to do that is as follows. This is going to be negative 2 times negative 4, and then we equate that to 0. And the way this simplifies is as follows. Lambda times lambda is lambda squared. Lambda times negative 3 is negative 3 lambda. 1 times lambda is negative lambda, and then negative 1 times negative 3 is positive 3. And then here we have negative 2 times negative 4 is positive 8, but we have a negative sign there, therefore negative 8 is equal to 0. Therefore this simplifies to lambda squared 3 lambda minus lambda is equal to negative 4 lambda, and then 3 minus 8 is negative 5 is equal to 0. So therefore this, when we simplified, when we let the determinant go to 0, we got a polynomial in lambda. We want to solve for lambda, and when we solve for lambda we're going to arrive at the eigenvalues. So to do this, we're going to use the quadratic formula. If the standard form of a quadratic equation, we said, is of this form, isn't it? Ax squared plus bx plus c. Let me write this x a little better. Bx plus c is equal to 0. And if that is the case, if we want to find the value of x, the formula, when we use the quadratic formula, we can write it out as minus b plus or minus the square root of b squared minus 4ac, the whole thing divided by 2a. That is the quadratic formula. In here, we want to recognize the values of a, b, and c. The value of a here for our given problem is a equals to 1, b is equal to -4, and c is equal to -5. We want to find the value of lambda, and therefore lambda is going to be equal to minus b, which is negative of -4. The formula came with a negative sign. The value of b takes on a negative value, therefore -4, plus or minus the square root of b squared, -4, the whole thing raised to the power of 2, minus 4 times the value of a is 1, the value of c is -5, this whole thing divided by 2a, 2 times 1. We will simplify the math in here, and when we simplify, it simplifies as follows. This is going to be positive 4 plus or minus the square root of -4, the whole squared is positive 16, and then -4 times -5 is going to be equal to positive 20, the whole thing divided by 2. Therefore, we can simplify this to 4 plus or minus square root of 36 divided by 2. Therefore, when we simplify this is going to be 4 plus or minus 6 divided by 2, because the square root of 36 is 2. Therefore, we have two answers for lambda. The two answers for lambda are lambda equals to 4 plus 6 divided by 2, which is going to be equal to 10 divided by 2, which is 5. So lambda 1, I'll call that as 5. And then lambda 2 is going to be 4 minus 6. The second time we're going to take a negative sign, and then when we simplify that, it is going to simplify as follows. 4 minus 6 is -2 divided by 2. That value is going to be equal to -1. Therefore, lambda 2 is equal to -1. So we found these two are called the eigenvalues. We found the eigenvalues for this problem. The eigenvalues for this problem are 5 and -1. We want to find the corresponding eigenvectors for these eigenvalues. So to do that, we're going to continue that in our part 2 of the presentation. Part 2 of the presentation. We will call this as part 1 of the presentation. Go to the, we'll erase this part here. We'll try to move up a little bit more. Yeah, we'll call this one as part 1 of the presentation. And then in my next presentation, which I will call that as part 2, we will continue from where we left off in this part 1, and the place where we left off is we have determined the eigenvalues, and we will now find the corresponding eigenvectors for these eigenvalues. I will see you in part 2 in just a minute.